Okay, so let's continue with the NumPy part. Here, what we have is just creating, and I won't go into every detail on the slides because it's too much. There are some cases where it's good to have only ones or only zeros in a matrix, and you can start with them. So there are functions to create matrices that way. There is the matrix which is called the I, where everything is zero except of these numbers here. Okay. You can create random numbers. Okay, so sometimes it's useful to start with a matrix that has just not random numbers in there. So you can use NP random to generate random numbers. Whatever, not that interesting for now. Random with integers, same. I'll try to find something which is more interesting through these slides. You can do also like other type of operations like division, but because we took integers and divided by some other integer, what we get back is a matrix of floating point numbers. Okay, just as outside in Python you would get floating point number. You have all kind of methods on NumPy like transpose and standard things that you would do with matrices. What's important to know that even if we call transpose and we get back a new matrix which is now transposed, this is not a copy of the original matrix, meaning that if I change one of the values in the original matrix, okay, and we got it, then we got it in the original matrix, then even the transposed one has it updated. Okay, so by default, it doesn't copy the whole data, which is good because it will give you the option that if you would like to, then you can copy. But if you don't want, then it won't waste extra space by creating a copy of all the data. If you would like to copy, then well, you have a method that will copy the whole matrix. Then you transpose it, and now you have two matrices basically, and one of them you can change. You changed. We saw element-wise operations when we had one matrix and multiplied by a single value or added a single value. We can take two matrices and add them together, and then each number will be either added together or multiplied together or whatever is needed there. So here you get here 1 and 7 were added and we got 8. There are several ways to multiply matrices depending on whether you want to one element by element or add them together, or there were various ways to do that mathematically and also in Python. So you can take a look at them and use whatever you need to use. In this case, okay, we have numbers, but as strings in the original list. So they might come from a source that you read where you have strings. So you might have read them from a file. And then we can use the S-type method to convert them in all the values into the same type. You have to yeah, that's it basically. Okay, here what you have see is the exception that I'm trying to add 1 to the old values of the matrix, but we can't because these are strings and this is a number, and the addition is not implemented for between strings and numbers. We can get to certain elements or part or slices of elements inside the matrix. That slice is also a reference. So if you make some changes, let's say to the original matrix, original vector, it will be reflected both in the original and also the slice. So this B is really not a copy of the data by default. It is just referring to the same data in the same place in the memory, which again is good because by default we don't copy data, we don't duplicate a lot of data, we don't waste memory, and also it allows us to refer to the data in a simpler way. Okay, but if you would like to change, but if we really want, we can copy the data and then like this. Okay, we take a slice, we copy it, and now these are just copied data. Okay. Yeah, okay, right. Okay. I was thinking that I was missing something, a slide, but no, it's here. So let's, what if you'd like to call up the absolute function of on each value of the matrix? So, which is a very simple thing. The reason I have here is because when I was originally asked about this, I didn't know about the existence of the absolute function on Numpy. And you're going to see the solution I gave, which is a very good solution for all kind of other cases where Numpy doesn't have the solution. But then later on, we found out that Numpy actually has this absolute method. And so here we didn't need this solution. So what does it do? We have a matrix, okay, with some negative numbers, some positive numbers. Fine. This is what we have. We can call np.absolute. So this, notice, this is not a method of the matrix. It's a method of the Numpy library that receives a matrix and returns another matrix. Okay, so this abs A will contain the absolute values of the original matrix. Each value, just the absolute number. Not very fancy. Probably you don't need it in your area of use, but it can be useful in some other area. Another thing, okay, before I show you the thing that I mentioned, that how to implement it if you don't know that there is an absolute function. The other thing that we also had to deal with, and we had the same issue, is that we have, let's say, a vector where it has Boolean values, so true or false. And we would like to do a logical NOT, so converting each true value into false and converting each false value into true, so flipping them over. This is the logical NOT. And apparently, Numpy also has a function called logical NOT that you can use. Again, it's on Numpy we use, and give it a matrix, and it will return a matrix. So if the original matrix was true, true, false, then the inverted, Boolean inverted, will be false, false, true. Okay? It's also interesting that if you have a, where is it? Yeah. So this is a sort of a strange thing, the next one. Or again, I guess it's just an arbitrary decision of the developers of the Numpy library, that if you put together some Boolean values and some numbers, in this case integer numbers, then it will automatically convert all the Booleans to ones and zeros. True values will be converted to 1, and false will be converted into 0. Why? I am not sure. Okay, I don't know why this was the decision to that made. I do know that in some languages they don't have these special true and false symbols, and in those languages it's usually 1 representing true and 0 is representing false. So this is the same logic here, but I don't understand why they allowed this, and instead of saying no, all the values must be either Boolean or all the values must be either integers. No, they decided to convert them like this. Okay, but if you call logical not on these integers, then they will be acted upon as if they treating everything which is 0, not everything, treating 0 as being false and treating everything which is not 0 as being true. And because I called logical not on it, now they are inverted. So these became true, these two, and all the other 3 became false. Okay, and this again, probably you in the biology and all these sciences, you won't need it. I needed it or at a company where I was teaching, and they were doing hardware engineering. And for them, these low-level engineering, chip design, and all kind of other things, so basically very low-level computation, they exactly are dealing with this Boolean values. So what we can do, if we didn't have the absolute function that we did at the end, if we don't have this Boolean not. So there are these functions, and Numpy is very wealthy on these functions. But you might create a new function, you might have a need for a new function that will operate on every value in a matrix that doesn't exist. Okay, maybe you come up with some function. So how can you do this in a nice way? Well, you can implement the function for a single value, okay? And then you can vectorize it, meaning you can convert it for NumPy to work in parallel on all the vector at the same time. So you won't need to write a loop on it. How do you do this? And so here we have a new example, not the absolute and not the logical the Boolean. We have a function called Fibo, which computes the Fibonacci number. Okay, we saw something like this. I think it gets an n. If it's 1 or 2, it returns 1 because that's the nth Fibonacci. And if it's a bigger number, then it will use this strategy. I don't think that we saw this implementation, but it will go with this loop, and at the end it will return the nth Fibonacci. So far, nothing fancy. It doesn't know anything about matrices, NumPy, nothing. It's just a plain function that we could have written earlier without NumPy. Okay, we can even see it. You can call Fibo 12, and it will give me 144. That's the Fibonacci number there. Okay. For this, I think you can forget. Don't worry about it. We can then take the NP vectorize. So it's part of NumPy again. NP vectorize, give this a function. So now the function is the parameter, not a number, not a string. The function itself is the parameter, and it will return another function, which I called vFibo because it's the vectorized Fibo. And now if I have a matrix, okay, a vector basically, I can call this one, the vFibo on the matrix, okay? And I get back a new matrix. So I gave it a matrix, and I get back a new matrix, which is the Fibonacci. It called Fibonacci for each one of these numbers, and then this is what it returned. Okay, so this can be very powerful. Let's say you have an Excel file, or I don't know. You have a huge a vector of many sequences, let's say, okay? And you have some function that we wrote in the previous assignment that does some computation on a single sequence and returns some value, okay? This was the assignment in the previous assignment, okay? And now you can take that and vectorize it, and suddenly you can use the same function on the whole matrix with just one single call. You don't have to you don't have to think whether it's a one-dimensional matrix, two-dimensional matrix, three-dimensional matrix, 27-dimensional, whatever. Okay, you don't have to think about it. You don't have to write a loop for it. You don't have to do anything. Actually, I quite like it now. This idea of running on many sequences the same function that you did. And so here there is another example. I think NumPy doesn't have this one, which is a very simple function, but it doesn't have, I think. Maybe it does. Maybe it has it since I wrote this slide. I don't know. There is the regular len function of Python, which will return the length of something, let's say a string. And here we have a vector of strings. We vectorized the len function into vlen, and then we call vlen on this vector, and it will return us the lengths of each one of the strings. Okay, let me show you something else that we haven't learned. So there is a structure, there is a thing called lambda in Python. Okay, we haven't learned it. Now we are learning it in the context of NumPy, but this is nothing to do directly with NumPy. It independently of NumPy, this exists. Lambda is a way for Python to create a function, basically, a very short function that doesn't even have a name. So this lambda thing is basically a function. This keyword lambda is basically defining a function that has a single parameter called x, and a single statement which is comparing len x, the length of x, to 5, and returning the result. What is the result of this? Well, it's either true or false, right? The length of the string is either bigger than 5, greater than 5, or not. So this expression will return either true or false. So this is basically a function. I could have defined it using the def keyword that we did earlier, okay, where we defined functions. And then it would have a name and so on. But we don't even need to do this because we can create on the fly and pass it as a parameter to the vectorize. And now it created us a vectorized function based on a, let's call it a virtual function, okay, that doesn't have a name. In Python, we call it a lambda function, okay, because that's the keyword. So it can be very useful. Right, and then we can call this function on a vector of the same thing that we did earlier, right, with the len, but now actually very similar, but now it will return true or false depending on whether the name of these animals is longer than 5 or not. Okay, so very good. Now I just remembered something related to this and related. I already thought about it earlier, but then I forgot promptly. So and something that's I would want to say anything. So I think I mentioned already this website called Meetup, that is a platform to organizing events. Okay, there are many groups in the world Some of them are dealing with programming, some of them are dealing with hiking or whatever. I personally run 3 groups now. This one is new. I closed my hiking group because I didn't do any of that anyway. So now I have this one, not relevant for you because it's about Rust. There are these 2 that might be relevant to you. One of them is called PyWebIL, which has meetings, usually in face-to-face meetings, and we give presentations about Python, in most cases in Hebrew. Okay, so this is relevant for the Hebrew speakers. I would really, really recommend you to join this club, okay, this group, and you will get notified when there is a meeting. For example, let me open it. The next meeting is going to be July 8th in a company called Data Rails in Tel Aviv. Presentations are Hebrew. We are still working on the exact presentations and so on. That's one thing. By the way, it doesn't cost any money, not registering on this website, and most of these meetings don't cost you any money either. The other group, and this will be relevant, this can be relevant to everyone here, is called Code Mavens. And I don't think, oh, I clicked on it. Okay. In this group, it used to be for other stuff as well. So there is still one presentation that's in Hebrew, this one. But now I'm converting it into a group where I only run presentations, virtual presentations, so in Zoom like this one, in English, about 3 programming languages, and one of them is Python. And the special reason I'm mentioning it now is because today in the evening, there is going to be a meeting, virtual meeting. So basically it's a presentation like I'm giving it now. And after that, we'll have a discussion about what we call functional programming in Python. And what is functional programming? Well, for example, what I've just showed you using this Lambda and a couple of other things that we haven't learned, this is called functional programming. So it's one of the more advanced way of programming Python. Okay, and I'm going to give a presentation about this. And we had you can still register. I put the link to the specific event. I put it here in the chat now, but I will also put it in the notes, the link to the group, so you can register either on this one or the other one, or both. There is also another group, and I couldn't copy paste now. Let's see, PyData TelAviv. Yes, that's the address. Again, this is, I think the presentations are in Hebrew. This is a website, this is a group about PyData that can be very relevant to you. They don't have a scheduled event now. You just have the past events, but if you register, you will be notified when they register an event. So you can learn new things in these events on how to deal with data. You can meet other people and start talking to them about this, and that will at the point when you're looking for a job outside of the academy, it will help you. I would also mention that there are going to be conferences. They're also here talking about the conferences and the others. So if you go visit, well, those who are interested in conferences in Israel especially, most of the presentations are usually in Hebrew, so it's only relevant to those who speak Hebrew. But this website tries to contain the list of events, of Python-related events in Israel. So you can check them out and so on. If we go back for a second to this one, the functional programming. So we had 2 days ago, actually, I had ran another event here virtually, and that also can be relevant to you because where is it? past events. It's testing Python. So I introduced testing more deeply, I think, than what I showed you in these meetings. There is the video recording that comes after this one, so you're welcome to join that. Or sorry, watch the video. And that came all of this I remember because we were dealing with the Lambda, and Lambda is frequently used in all these functional programming things. Did I send actually this link or just no? I just sent the link in the chat. Okay. Any questions, by the way? Right. Okay. So this is an example of how to filter some data. So here we have again the list of animals, and we have a vectorized function longer than 5 that we saw earlier. Okay. This is the function that returns true or false, whether the string is longer than 5 or not. And we vectorized it, so now it can work on a matrix. And we called it on the animals, and we got back a matrix of false and true values. So far, that's what we saw in the previous slide. Now, what we do is we take the original vector and we put square brackets, and then we put here the new vector that contains true and false values. This will create us a new vector that only contains the values from the original vector where we had true in this second vector. Ooh, I think I made it too complex. Basically, we got a vector of all the animals where the name is longer than 5. So we filtered the original vector to contain only the ones with long names. Now, this was a totally arbitrary function. You could have used any function to do anything to filter out your data. Okay? In this case, we have a matrix of just numbers I made up here. We have a condition, and we don't scores greater than 20. I'm not sure. I don't think that we need the parentheses here actually. Let me try this and fix it if we don't. Yeah, but I think I used the parentheses here in order to emphasize it because it was clearer, so we can keep it. Okay, so basically this is a condition, right? Scores greater than 20. Now, if scores was a single number, then this expression would return a single true or false. But because scores is itself an array, a Numpy array, this will return a Numpy array where each field will be true or false, depending on whether the value there is greater than 20 or not. So if I print out the original matrix, we get this. If I print out the high scores Boolean matrix, then this is true, true, false, false, true, true, false. So just true or false values. And now I can use this new matrix to filter out the high scores from this matrix. So I can write scores and put in square brackets the filtering thing, basically a matrix that is the same size, the same shape that the original one. Each field is either true or false. And then what we get back, and now what can we get back? Either we get back a matrix where you have holes, okay? Or, and this is what they decided, we're going to get back a vector of just the numbers where this internal matrix was true. So it could have been fun to get a matrix with holes in it, but maybe it's more useful this way. More of this filtering. On NumPy arrays, and that can get interesting. Okay, so here we have a NumPy array, just some array, doesn't matter. We have all kind of these statistical methods, basic ones like sum and mean and standard deviation and variance. Okay, I really don't know why they didn't use the full name of these things, but we have to remember. Okay, so these methods, minimum, maximum, sort of cumulative sum, I guess this is. Oh, this will be interesting, especially if you're coming from Matlab. But you also have it in R, so it's the same. So basically, in Matlab and R, you have all these matrices. And now the question, okay, if someone in the lab have some Matlab project, or I personally had some Matlab project that created some data and save it as .mat files, or I think that's how can I read it in Python and vice versa? So if I generate something from Python, some analysis, how can I read it later on in Matlab? So basically, how can the two interact? And that's what we'll see in a bit. So here we have just a plain any matrix, okay, doesn't matter, just some vector. And I can use np.save in order to save it. And this is going to use some internal format of NumPy. Okay, so it's not yet talking about Matlab. We're talking about saving the data into on disk. And so let's forget a little bit what I said about Matlab. Just focus on this one. You have some computation. You generated some results. Now you would like to save it. The easy way to save a matrix is by using this np save, give the name file name and the matrix, and it's saved. And then later on, you can load the same data by calling np load, giving it the name of the file, and you get back the same matrix. Whether it's in the same program or different program, later on, whatever. So that's a useful, easy way to save a whole matrix somewhere on the disk and maybe send it to someone else. Now coming to the Matlab part, there is the SciPy. Yeah, in the SciPy library of that comes with that can be installed for Python. There is an IO submodule, and then I can use the scipy.io.load function to load a mat file. So a mat file is basically very similar to these data files that we stored earlier. It contains, it can contain maybe more, but I think it contains one matrix is saved by Matlab. Okay, so here I'm calling load mat. I get back mat. Actually, it contains mat in square bracket. I have to put data, and this is the NumPy array. So it's not. It doesn't contain the NumPy array or the data purely. It contains inside this data thing, or at least this is how load mat loads it. Okay, so now I have this data inside. So if you generated some mat file with Matlab, I can read it into Python, into NumPy. And with save mat, I can create a mat file, which can be then used by Matlab. Not that interesting. An example with uint, okay, another type of integers in Python. Actually, this is what we saw here. You might remember, not here, here. About Rust, I was talking about having some of these 8-bit things between 0 and 255, and another one between -28 and 127. Same range of or same number of values, okay? They can both contain 256 different values, but one of them is from this range and one of them in this range. And the difference between these two is this is called unsigned integer, so without a sign, without a negative sign, and this is signed. So this one has a sign as well, and this one doesn't have a sign. Okay, it doesn't really matter. It's just how we represent some data. And if I go back, this is basically the same as Numpy. There is the int 8, which is a signed, and the uint 8, which is unsigned. So the unsigned would be able to go from 0 till 255, and the signed is minus 200. So the other range, okay, the minus plus range. Yeah, okay, it's just showing that part. So you can, by the way, you can see that in Python, in pure Python, you don't have this low-level dealing. In NumPy you have, and in the Rust programming language you always have. So you always have to think about all of these things, and it makes that language more difficult to write on one hand. Okay, my voice is going away. Probably means I need to stop talking and have a break. So Rust makes us deal with these things, but it also makes the code way faster than in general Python is. It's comparative to NumPy. Just for the whole everything. Trying to see what else there is. Not much. So we can deal with pandas next, but I will do it in the next video, not now. We have 10 to 11 now. So I'll talk a little bit about some other small stuff, and then next video we'll go into this one. Actually, this is not even directly related to the course. There is one thing. So I already talked about meetups. Let me talk about another thing. Exercism.com, not exercism.com. Yeah, they didn't write the website correctly. I put the link here, and I will also include it. I'm not sure if I mentioned it, but repetition is valuable. This is a website, can be very useful for people trying to improve programming, learning and improving programming. You pick a language, okay, let's say Python in our case. You get all kind of assignments that you download, you implement, you even get the tests, so you can verify that your solution is correct, which itself, this already itself is very valuable. But then comes the even more interesting part. You can submit your solution and ask for the volunteers of this website to comment on your solution. And then these volunteers, in their free time, it can take a day or 2 or 3 or maybe more, they will review your code and give you feedback on how you might improve your code, your solution. You can also see lots of solutions of other people if you don't want this personal feedback. That can be also useful. Okay, so and then you can go on for more exercises. This one has apparently 140 exercises. I played with it quite a few. I was also the mentor on various of these tracks, language tracks. I even wrote some of the exercises back in the days, like 10 years ago, for another language, doesn't matter. I would really strongly recommend, if you have the time and the interest, to improve your programming, because the key, to my understanding, with programming, and I guess in general, learning skills is practice and getting feedback, hopefully positive feedback, improvements, how you can improve things. That's why I wanted to. That's why instead of giving you a grade and on your and taking all the mistakes and saying, oh, you have all these mistakes, so I give you a lower grade. Instead of that, what I was preferring to do is to basically comment on your code, and this is what I did during most of the assignments, and let you fix those things. So basically, I don't have to reduce the grade, and you're learning. Okay. So this is a platform to do it, and people are volunteering. And the even better way to improve yourself, if you would like to improve, let's say, your Python knowledge, is that after you did some of these assignments, you become a mentor, basically reviewing the solutions of other people and commenting on them. That will give you, that will force you basically to read other people's solution and to think about other solutions and why that might be better or worse, or how could you improve. Again, I guess that you are way too busy with all the other things that you are doing, so I'm mentioning it here. You can put it away, and then later on, when you in your free time, when you go to retirement or whatever, you can get back to it. Some people will do, most people won't. It's fine. I do occasionally this. I like it. This is another thing. And the third thing is I wanted to show this website. Probably many of you are familiar with it, maybe not all of you. I can, in SubGub, let's see my profile, not just what I get randomly there. So this is sort of, some people are describing the Facebook for finding jobs, sort of. If you're not familiar with this, basically it tries to build what they call business connections, but basically you put up your CV there, basically describing what you studied, what you worked for, what knowledge you have, and then you connect with other people, and through this, quite a few job openings go through this. You also can search for jobs here, and so on. I would recommend that you, if you don't have it yet, you create a profile here and slowly connect to people who you know, because those connections will help you eventually find some job. You don't have to be active here, like in a social network, only when you're looking for a job or trying to figure out. And the key thing that I'm trying to explain to people is that, let's say you found a company, you would like to work there, and now you know that if you can get a recommendation from someone inside, that would go a long way of getting a job. But you don't know who works there. With LinkedIn, you can, if you are interconnected to many people, you can easily find whether someone you might personally know or who is related to someone you personally know already works there. So I'm connected to people I know from kindergarten, okay, in Hungary. So they might be connected to another person who works as some important or just an employee at a company where I would like to work. I would never find this out, okay, without some platform of connection. So I would recommend you to join this. I would also recommend to connect to each other, connect to every person you studied with, or you went kindergarten to, or your kids are going to the kindergarten with their parents, or what? No, sorry, the parents of the kids that your kids are going to kindergarten. together. So everyone, and I also put here my profile, so you're welcome also to connect to me, and so on. So that's it for now, and I'll have a break, and then we're going to cover in the next hour. That's going to be our last meeting of the course. I'm going to talk a little bit about pandas and a little bit about machine learning part, or yeah, that's it. Data science, machine learning thing. So see you in about 10 minutes.